So we are starting in on chapter 2 today. Um, I'll give you a moment or two to search through your packet. I know that there was homework and stuff between the chapter 1 stuff and the chapter 2 stuff. So might take you a moment or two to find this stuff. Chapter 2, they call it basic concepts for proof, artist and proof. Proof is going to get to be a larger and larger topic over the next couple of chapters. These are really the nuts and bolts that we will be using to tie a bunch of other concepts together. Things like addition, subtraction, multiplication, division will find their way into proofs. We won't actually be doing any of those things. I'm not going to be testing your addition skills or anything like that, but we're going to talk about the concept of addition, subtraction, multiplication, division. And thank you, Kat, for getting right into my document again. Wonderful. Keep going. Okay, looking at the right-hand side of my screen, I see that we have a lot of people here now. That is awesome. 16 minus the 2 that are me, it's 14, and I know that we have one person out, which is why we are recording this. So we are ready to go. Today, very straightforward. There's only one concept, and apparently it is not on page 2 because nothing is on page 2. But here it is. It is the concept of perpendicular lines or perpendicularity. And by the way, they wrote it right here out perpendicular, but we spell it just like that, an upside down T. So if I ask you how to spell perpendicular, it's kind of a trick question. It's just that upside down T. I like this symbol. It really is what it says, and it says what it is. Not entirely sure what they expected us to write here. Obviously, we can write this in a conditional, but there are a number of different definitions for perpendicular lines. And at this point, I really don't care whether we're talking about lines, segments, or somewhere in between, rays. I say what makes segments perpendicular is that they lie upon perpendicular lines. So I'm going to write this in an if-then form. I could say if lines are perpendicular, how do I spell perpendicular? Just like that. Are perpendicular, then they intersect at right angles, that's fine. Then they form right angles is how I usually say it. Form. And right, I leave out all the middle letters, so just RT angles. And I see a question. Yeah, Colin.
Where is this? I can't find this in the packet.
I know, it's way far in there. I started like throwing out pages left and right. So this is the beginning of chapter 2, which comes sometime after those chapter 1 notes.
Okay, I see. Yeah, there's a lot. Okay. Thank you.
Oh, no worries. It took me forever to find it. Not in love with how it is organized, but also I understand that the ones who organized this thing were not planning on doing it online. Okay, as I said, there are a number of different ways of writing this definition. One of them is the converse. After all, it is a definition, so inverses and converses definitely on the table. I can tell you flat out that we're probably not going to deal with the inverse. The inverse deals with things which are not perpendicular. Truth be told, the big money, I like big money, is in proving things are not. We're not going to do it for a while. Okay? What do I mean when I say the big money is in proving things are not? And I'm going to switch my view here so I can see if like anyone's like raising their hand or anything like that. Who gets paid more? The prosecutor who works for the government or the defense attorney who works for a client on trial. Yeah, Ramsey.
Defense attorney?
Oh, absolutely, 100%. The defense attorney, they can charge whatever the heck they want. They make a lot of money. In fact, I can't even estimate how much money was made on one particular conditional sentence. I'll say the beginning of it. I wonder if you guys know it. If the glove does not fit, yeah, finish it. Go ahead.
Must acquit.
Then you must acquit. Absolutely. That was from the O.J. Simpson case. That was something that the defense came up with and proved that he was not guilty. By the way, in cases like that, you can plead not guilty, which is what everyone does, or you are allowed to plead innocent, which nobody does. It's way harder to prove that you're innocent. So to prove innocence, you have to prove that he could not have done it. Or to prove not guilty, you just have to show he didn't have to do it. Okay? So it's the prosecutor's job to prove that he did do it. It's not the defense's job to prove that he didn't do it. It's just to show that he didn't have to do it. Everyone confuses it and says, oh, well, beyond a shadow of a doubt is, no, it's beyond reasonable doubt that you have to prove. Anyway, back on it. So I was saying that defense attorneys, they make the money by proving that things are not. We're not quite there yet. Also, of course, social justice issues. We want to prove that certain things are not, or certain people are not guilty, or any of that nature. So very, very important these days. If lines are perpendicular, then they form right angles. How about if lines form them they're right angles? Then they are perpendicular. The inverse and the contrapositive are true as well, but chances are we won't be using it because we're not proving that anything is not at this time. Okay. Those are two useful ones, yet there are more definitions. We could always use these ones and then take an extra step if it wasn't that I was trying to prove that angles were right. What's another way of saying right angles, of course? I'm sure you all know this, even though I don't see anyone rushing to answer. Another way of saying right angles?
Measure 90 degrees.
Sure. How about if, this time I'll say segments, just to change it up, are perpendicular, then they form, and technically angles whose measure is 90 degrees, but I'm just going to say 90-degree angles. I was doing math with one of the English teachers at the school yesterday, and they were putting these little apostrophes in, which technically they don't belong. So I pointed out to the English teacher that, that the apostrophes don't really belong there, but they look nice, and I put them in there, and she certainly was putting them in there as well. And next up, I'm just going to write the converse of this. Actually, I'm just going to write converse. So if segments form 90-degree angles, then they are perpendicular. And the lines, segments, rays, those are all interchangeable. I'm going to just write that. Lines, segments, rays are interchangeable here. Okay. Get that on the screen. Not so bad, not so rough, not so shabby. Did not really blow your mind first thing on a Thursday morning, I am assuming. Nobody looks altogether put out by this. except perhaps Lily, who I can't see. Okie dokie. Let's see where we might use this, both in a exercise and then later on in a proof. All right, so on the next page, we are given that these segments are perpendicular. By the way, segments, lines, and rays are perpendicular. Angles are not. That is something which I am looking forward to this year. For my first year in 16 years, I'm not teaching the low-level geometry. I am looking forward to not hearing every day about perpendicular angles. Angles aren't perpendicular. Segments, lines, or rays may be. All right, AB is perpendicular to BD. This one is AB here, and this one is BD here. So together they form a right angle. Find the measure of angle CBD. Well, what equation is kind of implied by what we've got going? What is the starting equation that I'm going to work with here?
X.
Oh, Nazi, yeah, what was that?
X plus 2x minus 3 equals 90.
That's exactly what I'm looking for. X plus 2x minus 3 equals 90. I don't need parentheses. Sometimes I put them in just to like kind of show, oh, that's one angle measure, that's the other angle measure. They don't do anything, they just kind of look nice. I used to say just like Mr. Greer, but Mr. Greer has really been helping out the department this year, so I'm not going to make as much fun of him this year as I do in the past. All right, from here, we're going to solve for x. I'm going to gather like terms. I find I have 3 of those x's. While I'm gathering like terms, I should add 3 to both sides. Equals 93. How about dividing by 3? I get that x equals 31. Remember to put in a degree symbol because that's what it is. And that's fantastic. I go off to the refrigerator. I get myself a snack to celebrate my triumphant finishing of this problem.
You still have to plug it in.
Okay, Mark, who has had me the horrible disadvantage of having me for 2 years in a row, realizes, of course, that is my sarcastic tone, that I was not done. A lot of people will just stop there, but that's not what they asked for. They asked for CBD, so I'm going to plug it in according to Mark's suggestion and multiply it by 2 and subtract 3. Others among you might notice that I really haven't jumped to it. Oh, Robert has an idea. Yeah.
You could also just subtract 90 from the 31.
I think I'm going to do that. No, you're not wrong. I could multiply by 2. It's not the hardest thing in the world. I could subtract 3. You know, all things within my my level of expertise. But I think it's easier just to remember, oh yeah, these 2 things add up to 90. So if one of them's 31, the other one, the measure of angle CBD, has to just be 59 degrees. Okay. Not that doing it both ways wouldn't help to check. 31 times 2, there's 62. Subtract 3 from that. Oh yeah, it seems to work. But either way, a true mathematician doesn't try to make more work, they try to make easier work for themselves. Okay, main event of the day, kind of. Squishing this into some proofs. I'd love to give you guys a little bit of a head start on this. I will sip my coffee and enjoy my morning, and I will let you guys start writing stuff down. Good coffee. I'm going to give you guys another minute or two, but just to make sure we're at least this far, I went for the low-hanging fruit and wrote in the givens. Maybe you wrote it in 2 steps, perfectly fine. I've stuffed it into 1. Okay, the entirety of the difficulty of this problem lies in the second step. Does anyone have a second step which they feel works out? Anything? Yeah, Robert, go for it.
If lines are perpendicular, then they form right angles.
Okay, that is a reason. I'm going to put it over here. If lines, and they said segments, you said lines, I don't care. That's fine. What makes the segments perpendicular? That they lie on perpendicular lines. No big deal. If lines are perpendicular, and again, the if part is still what I already know, so it matches, then they form right angles is what you said? Yeah, okay. And they form right angles. And of course, what statement does that support?
That they are both 90 degrees.
Okay, and in statements we're very specific. I'm going to say angle PSR, I believe, because
Yeah.
PS is perpendicular. Yeah, PSR, and put in an ampersand, angle QRS. QRS are right. Now, Aaron, you had your hand up as well. Did you go the same route? No.
Me? Yeah, I did.
Oh, you did. Okay.
Same thing.
Not that it's the only correct answer. So if you're like, oh man, I wrote 90-degree angles instead of right angles. Oh, I screwed this up. No, you could have gone that way, but they would have to match. So maybe you wrote if lines are perpendicular, then they form 90-degree angles. And over here you said angle PSR and angle QRS are 90 degrees. Perfectly fine, perfectly fine. Doesn't matter. You just all have to match up. Okay. So, I feel like we're a good way into the process of making some tea here. Yes, Sienna.
Maybe if 2 angles have the same measure, then they are congruent.
Okay, I love it if we had said 90 degrees. If then maybe you did. Maybe you said if lines are perpendicular, then they form 90-degree angles, and that these are both 90 degrees, then I know something about their measures. But if we went this direction, I don't know anything about their measures. Nobody's told me anything about their measures. How am I going to make it match?
If they are right angles, then they are 90 degrees.
I could do that. I could now switch from right angles to 90 degrees. But let's not forget, we have a theorem which I think can take us home. And since I think we only have 2 theorems so far.
If 2 angles have the same measure, then they are congruent.
If two angles had the same measure, then they are congruent, I think is exactly what Sienna said. I don't know their measure. And if I haven't made it clear, all these answers, which aren't quite there yet, are fantastic, people. This is, this is the heavy lifting. You guys are doing it.
If two angles are right angles, then they are congruent.
Hey, that's a theorem which gets us from what I already know, right angles, to what I'm trying to show, congruent. If two angles are right, then they are congruent. The if part is what I already know. I know that they're right angles. The then part is what I'm trying to show. I'm trying to show that they are congruent. That gets me home. Angle PSR is congruent to angle QRS. Now, for those of you who are saying things like if two angles have the same measure, then they're congruent. Of course you are right, and of course that is fantastic. And of course that makes some great degree of sense. The problem is kind of a weird problem. The problem is you guys are too smart, and you are talking to someone, like, you don't mind me saying, my geometry persona, who's not smart at all. My geometry persona needs to be walked through step by step. I won't make the connection that this says right angles and you said same measure. I don't know that right angles have the same measure unless you spell it out. So again, I could have done it in different ways. Did anyone do it in a different way? Did anyone go with the 90 degrees and same measure, consistent all the way through? William did. Awesome, awesome. Love it. This is one of the big reasons why I don't have answer keys for my tests. I don't look to see, did you do exactly what I did? No. I go, does what you did make sense? And hopefully the answer is yes. I am at odds with this next exercise here. We're going to do it just because we have a little bit of time, and it's not that it's bad or anything. It's that this book, despite the fact that it clearly has different authors who did different things at different times, this exercise seems out of place. It's talking about this grid and assuming that we know certain things, which it's going to teach us later, even though I'm pretty convinced you guys already know it. So find the coordinates of point B. This is a standard Cartesian coordinate plane that you used in algebra or algebra 2 or anything like that, just normal X's and Y's. So what is that point? I just put a dot there. The point is
10, 8.
10, 8, absolutely. It is directly above C, so it has the same X value. It is directly to the right of A, so it has the same Y value. This is the point 10, 8. It sounded like Aaron who said that. No? Okay, someone else said it, sorry. Oh, Nazi? Nice, okay. Very, very nice. And then really here's the point which I very much disagree with. They asked me for the area of this rectangle. Not that you guys shouldn't be able to find areas of a rectangle, but officially we don't teach it until chapter 11. So it seems a little odd that they threw this one in here. We know, hopefully we know how to find area of a rectangle. Most of the time people tell me it's length times width. When we get there, I will try to convince you that base times height makes a little bit more sense. Not a ton more sense. Or heck, we could count up the squares. We got 1, 2, 3, 4, 5 rows, and 1, 2, 3, 4, 5, 6 Those are the columns. Did I count that right? No, 7. 1, 2, 3, 4, 5, 6, 7. Hey, counting is hard. What did we say? 7 by 5. So it looks like this thing has an area of 35. They didn't give me any units. So I like to say units and then put another little symbol here, which looks like I wrote units square, but it should be pronounced square units. You don't write the square first because then it looks like you're squaring 35. Okay.
Block is 2 by 2 square, so it would actually be 14 by 10.
Did I miscount? Are they going by 2s here?
Yeah.
Oh, well, good. I'm glad, because this brings me to a point which I did not mean to make, but I will happily take anyway. That you're telling me that that it's really I counted the boxes instead of counting the things. I guess each box could be a square unit here because they didn't really say. But in reality, we are going to. Am I going to double my answer to get the right one? No. What am I going to have to do?
You're gonna have to like subtract from the coordinates.
Yeah, I could subtract the coordinates, but to get from my wrong answer to my right one, what should I multiply by? I assumed that all of these were ones. 1, 2, 3. Whoa, that's weird. Are they just like totally weird units here? No, they're going by 2s. You want a kitty? I don't know where your kitty is. What do I have to multiply to get that correct answer?
By 4.
4.
I hope I heard by 4 there. Sorry, my daughter is searching for a cat in here. Yeah, I have to multiply by 4. Seems a little bit weird. I was off by 2, and now I have to multiply by 4. I won't really get into why that is until chapter 11, but it's kind of neat. And it's definitely a mistake that that we see all over the place, including in pasta makers, oddly enough. Anyway, more on that later. Guys, we've been at it for a whopping 29 minutes, and I feel like we have completed what we need to complete today. If you haven't already handed in your test, it is due in, what, 26 hours? Plenty of time. Hopefully that is either done or well underway. But we are going to call it a day today. Let me stop this recording and